Hello all, welcome back to Engineering Economy. We are continuing our discussion, and in this lecture we will start a new topic, which is chapter 7 in your book, which is about depreciation. And in this lecture we will learn what is depreciation, where and how do we use it, what are the terminology related to depreciation, and we will see a number of different depreciation methods, and we will solve several examples. So let's get started. Depreciation is defined as the decrease in value of physical properties with usually passage of time and use. So we will see different depreciation methods, and you will see that in these methods we use the time and use of the assets or physical properties as the factors that decrease the value of these properties. So when we say depreciation, you should understand that there is a decrease in the value of physical properties, and this is meaningful. Think about the cars. Assume that you bought a car, it's a brand new one, and as you use it for 1 year or 2 years, okay, after 2 years, even without using it, if you put that car directly into a closed door garage and wait for 2 years, and after 2 years, if you want to sell that car, you will not be able to sell it in the same price that you bought it, because now it is a 2 years old model. There is maybe new technology, new cars with the new concepts, and your car is 2 years old even without using, and it lost some value. And if you use it during these 2 years of time, if you continue to use your car because it's because of wearing out, because of maybe you have some accidents, because the tires are worn out, the engine may have some failures, and etc. Due to these factors that depends on the usage, it also loses from its value. So depreciation is a measure for this loss in the value of such physical properties. So it is an accounting concept, and it establishes an annual deduction in order to reflect the effect of time and use on the asset's value in firms' financial statements. So firms, either manufacturing or service organizations, have many assets, buildings, cars, machines, equipment, and etc. And as the time passes and as these assets are being used, they lose their value. And this loss of value should be reflected in the firm's financial statements. So when we are saying that this firm has many assets, then we need to know what's the value for that one. If they are brand new ones, then it may worth more. If they are older ones, then they will worth less. And to match yearly fraction of value used by asset in production or income over asset's economic life. So each asset has an economic life. So you put that asset into service at some time, and it has a useful life. And during this economic life that we say, during this economic life, this asset will provide some income. And but as a result of this use, it will lose from its value. So in order to match this loss of value with the production income over this asset's economic life, we use depreciation. And mainly, this depreciation is used to calculate the taxes. It's very important for firms to calculate their taxes, because if you, for example, usually the taxes for the firms are calculated based on the revenue, based on the annual profit. So you get some revenue, and you subtract the costs from this revenue, and that's the profit. And over this profit, the laws and regulations say that you give a percentage of this profit as a tax. But since you used your assets in order to provide that revenue, in order to earn that revenue, but this loss of value of the asset is not a cost, it is not reflected. And if you pay a constant percentage of this net profit as a tax, then after the economic life of this asset is over, in order to continue your service, your business, you need to buy a new item, and it will be an additional cost for you. So it is said that if by using an asset you produce an income, then since the value of this asset is reduced, you can reduce this loss of value of the asset from the taxable income. You can subtract it, although it is not a cost, it is not a cash cost. Since there is a loss of value, you can reduce that cost, this loss of value from your profit, and then pay the tax for the remaining amount. So all governments provide this for the business so that they can continue their operations. So some assets are depreciable, but some are not. In order the assets to be depreciable, they must be used in business, or they must be used to produce income. Okay, so this is one condition. Second condition, they must have a determinable useful life. And this useful life should be longer than 1 year. If the useful life is less than 1 year, then it's not depreciable. If the useful life cannot be determined, for example, you have a land. What is the useful life of a land? 10 years, 20 years, 100 years? What will happen to that land after 100 years? It's still a land and it's still useful. Okay, so if the useful life is not determinable, then that asset, for example, land, is not depreciable. And in order an asset, again, to be depreciable, it must wear out, it must decay, get used up, become obsolete, or lose value from natural causes. If none of these occurs on an asset, then it's not depreciable. And also, the asset must not be an inventory or stock in trade or investment property in order it to be depreciable. So the assets that satisfy these conditions are depreciable assets. The depreciable properties are classified into two as being tangible or intangible. The tangible properties are the ones that can be seen or touched. And these tangible properties can be divided into two main types, mainly personal property and real property. Personal property includes assets such as machinery, vehicles, equipment, furniture, and etc. Okay, and the real property are anything that are erected on, growing on, or attached to land. Okay, and since the land itself does not have a determinable life, it is not depreciable. So the land is not depreciable, but the real property is anything that is attached to this land. So these are tangible properties. And intangible properties are the ones that cannot be seen or touched, such as the personal properties. These are personal properties, such as the copyright, patent, or licenses. So these are also, although they are intangible, they are still depreciable properties. And the real property that are attached, for example, building is attached to the land, right? And it has a determinable useful life, and it is depreciable. We are not saying here that real property is not depreciable. I'm saying that the land itself is not depreciable because it doesn't have a determinable useful life, but anything that is erected on, growing on, or attached to this land is a depreciable property. So when depreciation starts and stops, the depreciation starts when this asset, when this property is placed in service. Look, we are not saying that when you buy it. We are saying that when it is placed in service for use in business or production of income. Okay, so you buy it. If this is a machine, you buy it, transport it into your facility and set it up for use. And at that time, the depreciation starts. Okay, the property is considered in service when ready and available for a specific use, even if you don't actually use it. But if it is ready and available for that use, then it is the property is considered in service, so you can start depreciation for this property. And depreciation stops when cost of placing this property in service is removed or it is retired from service. You sell this item or it is end of its useful life, so you cannot depreciate it anymore. Or we will talk about these values. It will have a cost. This item, this property will have a cost, and you can depreciate an item only for its cost basis. You cannot depreciate an item more than its initial cost. Okay, so the depreciation stops either when the cost of placing it in service is removed or when it is retired from service, whichever is earlier. There are several concepts that we need to learn about this depreciation. Usually these are some accounting concepts. In engineering, you may not be familiar with these concepts, so we need to go through several of these that we will need to calculate the depreciation. First of all, basis or cost basis. What is this? It's sometimes also called as unadjusted cost. It is the initial cost of acquiring an asset. Okay, buying, you purchase this asset, and in order to purchase, you need to pay some money. Okay, this acquiring cost includes the sales tax that you are paying, the transportation cost of that into your facility, and all the additional costs for setting up the property, the asset, and making it ready for the service. So all the associated costs are included in this acquiring cost or initial cost. So this is the basis, cost basis. Sometimes we may need to adjust this cost basis, and it's called, in that case, adjusted cost basis. And this is the allowable adjustment on top of these cost basis, original cost basis. And when we do these adjustments, it can be an increase or decrease on the original cost basis. And we do this in order to calculate the depreciation reductions or depletion reductions according to this one. It can be why we may need to adjust the cost basis. So we may do an improvement on the asset. We may improve it, but this improvement is a depreciable improvement if its useful life is more than 1 year, greater than 1 year, okay, or if there is a casualty or theft of the asset or equipment, then this is a reduction in the original cost basis, and we need to adjust our depreciation according to this. Okay, so the cost basis includes the original purchasing cost and any other cost like taxes, transportation, and service costs that we need to pay to make this asset ready for operation, for service. And adjusted cost basis is the adjusting of this original cost basis due to any kind of improvement that we do on this asset. So for example, you buy a car, okay, and then when you buy it, you make a change in its engine, you make a change in its tires and etc. Okay, you improve that car, and then this you need to use this adjusted cost basis in your depreciation calculations. Another concept that we need to learn is the so-called book value. And book value is the worth of depreciable property as shown on accounting records. Every firm has their own accounting records, and in these accounting records, they have all their information related to their assets, whether these may be physical assets, buildings, cars, and etc. And in all of these, for all of these assets, you need to write its economical value. And in these accounting records, the value that is written is the called book value. So a book value needs to be calculated each year for each asset. It includes the original cost basis of the property, including any adjustments, minus all allowable depreciation deductions for each year. So we will calculate the book values when we learn different depreciation methods. We will be calculating the book values of the assets. And this book value represents the amount of capital remaining invested in this property and must be recovered in future through accounting by not paying the tax of this, by deducing their value from the tax. So how do we calculate the book value? The book value in year K is equal to the adjusted cost basis. Okay, this is the initial cost minus all the depreciation deductions that we do during year 1 through K until this year K. So a book value of a property in year K is its initial cost minus the cumulative depreciation that we do until this year. Another concept is called the market value. Until now, in our analysis, present, future, worth analysis, and etc., we used actually this concept, so-called market value. By definition, market value is said to be the amount of money that a buyer is willing to pay for this property. Okay, so amount of money that a willing buyer pays to a willing seller for the property, where there is no advantage and no obligation to this transact. Okay, this is called market value. This market value approximates the present value of what will be received through ownership of this property, including the profit. Okay, this is the definition of market value. So if you want to sell this property in the market, for how much can you sell this? It's called market value. On the other hand, we also know the salvage value, and until now we use these terms interchangeably, salvage value and market value. We said that they are the same thing. Actually, there is a difference because as we said, the market value is the amount of money or the selling price that you can sell your item in the market. But the salvage value, on the other hand, it is the estimated value of the property at the end of its useful life. Okay, so this end of useful life is critical in salvage value. Let's assume that you have a car and its useful life is 20 years. So if you want to sell this car after 10 years before the end of its useful life, you can talk about market value, not salvage value. But after 20 years, when the life of the car is over, then its value is the so-called salvage value. So the market value at the end of the useful life is called salvage value. So this expected selling price of property cannot be used productively when the useful life of the asset is over. Okay, so that's why we use salvage value. If the useful life is over, then in some cases there is no value. The salvage value can be zero. But in some cases, you can still use the raw material. For example, if it's a machine, you can use the metal parts for recycling and etc. Therefore, they may have some value. It's called salvage value. But if it is market value, you buy the machine or car and you still continue to use for the same purpose. So the net salvage value, we can talk about the net salvage value. It is the value when you subtract or deduce any cost of disposal of this property. Sometimes at the end of the useful life, yes, you earn some thing from this item because of using the scrap metals and etc. for recycling. But in order to dispose that item, you may need to pay some additional money for chemical cleanup, for transportation and etc. So you need to subtract all these cash outflow so that you will obtain the net salvage value. We will here learn some classical depreciation methods. Okay, and actually we will learn 3 classical depreciation methods. And in these classical depreciation methods, we use the estimated salvage value of the properties, and we use these to calculate the depreciation amounts and the market values. Another terminology that we need to learn is the recovery period. So we have an initial cost basis, and we have the final salvage value at the end of the useful life. And during this period, it's economically living, this property is economically living, and the recovery period is the number of years over which we can use this property for depreciation through accounting processes. Actually, we will learn classical methods, and in these classical methods, the useful life is equal to the recovery period. But there are some other methods, MACRS methods and etc. Actually, they have different idea. We will not use this in this course. They are mostly related with the United States tax system. And in that case, the useful life and the recovery period can be different. On the other hand, then what is the useful life? So it is the expected or estimated period of time that this property can be used in service, in business, to produce income. So sometimes in accounting, this useful life can be referred to as the depreciable life. So we will learn, as I told you, the classical depreciation methods. And in these depreciation methods, basically we will do some calculations and we will use some notation in these calculations. So let's go through these notation. First of all, this N. N is the depreciable life. It is the useful life of an asset and it represents the number of years. B is the cost basis for calculating the depreciation. So if there are any adjustments and etc., this B is the adjusted cost basis. DK is the depreciation amount in year K. Okay, this is the annual depreciation amount. So D1 is the depreciation in first year, D2 is the depreciation in the second year, and etc. In these classical methods that we are going to learn, in the straight line method, we will have all these depreciations on each one of these years to be equal to each other. Okay? But there are some other methods like declining line method, declining balance method, or years of production method, and etc. In those methods, the depreciation in one year can be different than the depreciation in another year. And simply D1 represents the depreciation in year 1, the amount, and D2 is the amount of depreciation in year 2. Of course, when you have these depreciation amounts, let's say that D1 is the depreciation amount in year 1. Let's say we calculated it to be 100. Let's say D2 is 50 depreciation in year 2. D3 is 75 depreciation in year 3. Okay, so with D3 star or DK star, we will denote the cumulative depreciation until year 3, which is simply the summation of these depreciations until year 3. So 225, which is the summation, is the cumulative depreciation until year 3. So this BVK is the book value of the asset at the end of year K. So initially this book value will be equal to the cost basis. Okay, so BV0, if you say, initial book value will be equal to your cost basis. At the end of year 1, okay, this book value will be equal to the cost basis minus the depreciation during year 1. In year 2, the book value at the end of year 2 will be equal to the original book value minus depreciation in year 1 minus depreciation in year 2. Or we can write it like this: book value minus depreciation in year 1 plus year 2, and simply this is the cumulative depreciation until the second year. So book value at the end of year K is equal to the cost basis, initial cost basis, minus the depreciation, cumulative depreciation until that time, and we can generalize this saying that book value at the end of year K is equal to initial cost basis minus cumulative depreciation until that year. Okay, so all our calculations will depend on this formula. Book value at the end of depreciable or useful life, so this BVN represents it, and in classical methods, usually this BVN will be equal to the salvage value. This SVN will represent the salvage value at the end of year N, and simply we will use this salvage value in calculating these amounts. So the problem here, what is the depreciation in year 1? What is the depreciation in year 2? How can we calculate it? So we will learn different methods, different ideas to calculate this. And this R is the ratio of depreciation in any one year to the book value at the beginning of the year. Okay, so this is a ratio. If assume that the book value at the beginning of this year, B1 is 100, and the depreciation amount is 20, then R is equal to 20 divided by 100. Okay, this ratio is denoted by R. Okay, the first and the easiest depreciation method that we are going to learn is the straight line method. And in this straight line method, what do we have? Initially, let's assume that this is the timeline, and it starts at time 0 where you put this property into service, and it has a useful life of n years. And let's assume that initially the book value of this item is 1000. And at the end of n years, you estimate that you can sell this item for $200. Okay, this is the salvage value. And the straight line method says that, okay, the initial value of the property, 1000, will reduce, the value of the property will reduce from 1000 to 200 during these many years. Okay, year 1, year 2, up to year n. And the question is, okay, from 1000 down to 200 in n years. So in each year, how much this value is reduced? The problem is that. And the straight line method says that an equal amount is reduced each year. Okay, that's why it's called straight line. It goes from 1000 to 200 as a straight line. And how can we find this? Of course, you can find the amount of reduction at each year by simply subtracting the end value 200 from this initial value 1000 and dividing it by the number of years. Let's say this is 10 years. Okay, and here the value appears to be 800 divided by 10, it's 80. Okay, so what happens? It says that in the first year, the book value reduced by 80. So 1000 minus 80, 920. So it means that the book value in year 1 is 920. Then it continues in the same way. It reduces another 80, 920 minus 80, 840. So this is the book value at the end of year 2. Then it reduces another 80 and 760 is the next. And it continues to reduce 80, 80, 80. At the end of 10th year, the book value reduces to 200. This is the assumption. This is the method of straight line. So we can use the notation to write the formulas of this one. So the depreciation at year K can be calculated by the initial book value, 1000, this one, minus the final salvage value at the end of useful life, which is 200, divided by n, which is the useful life. So this 80 here is the depreciation in year K. And in straight line method, depreciation in year 1 is equal to depreciation in year 2 is equal to depreciation in year n. So what about the cumulative depreciation? So depreciation in year 1 is 80. Depreciation in year 2 is 80. Depreciation in year 3 is 80. It goes in like this. So the cumulative depreciation at the end of year 2 is 160. Cumulative depreciation at the end of year 3 is the summation of these two. It is 240. What is 240? It is 3 times 80. At the end of year 4, it is 320. It is 4 times 80. So the cumulative depreciation at the end of year K is equal to K times dk for all years up to n. And what is the book value at the end of each year? It's simply the initial cost basis minus the cumulative depreciation. Okay, so it is very easy method, and this method requires an estimate of the final salvage value. You need to know this final salvage value or estimate its value. Let's solve this simple example to understand it better. It says that a new electric saw for cutting small pieces of lumber in a furniture manufacturing plant has a cost basis. So it says that this B is equal to 4,000. And the depreciable life or useful life is 10 years. Okay, the estimated salvage value is 0, as V10 is equal to 0. It says determine the annual depreciation amounts using straight line method. So according to straight line method, what we do, we subtract 0 from 4,000 and divide it by 10, which is 400. So this is DK, depreciation amount at each year. It says tabulate the annual depreciation amounts and the book value. So what we can do, we can say that this is the number of periods. We can write here depreciation, simply DK. We can write here book value. And period 1, 2, 3, we can go in this way. The amount of depreciation at each year is 400, 400, 400. It goes like this. And the book value at the end of year 1 will be 4,000 minus 400, which is 3,600. At the end of year 2, we need to subtract another 4,000, which will be 3,200. Subtract another 4,000, and etc. And we need to fill in this table until the end of the 10th year. And if you do so, at the end of year 10, you see the book value reaches 0. Why is this 0? Because the salvage value was given as 0. If the salvage value was not 0, so let's assume that for the same example, the salvage value is not 0, but let's say it is 1,000. Okay? Then what do? We calculate dk as 4,000 cost basis minus salvage value divided by the number of years, so which is 300. Now in this case, in this table, when we fill it, we subtract 300 from here and it will be 3,700. Another 300 and it will be 34 and etc. And if you go like this, at the end of the 10th year, you will see that the salvage value will remain as 1,000. Okay, so it means that this depreciation takes the initial cost basis B and reduces these annual depreciation amounts, and at the end the final depreciation amount reaches to the salvage value. And here we do the calculations by using the 5th year as an example. Okay, D5 is calculated as 400, as you can see in straight line, all of them are the same. The cumulative depreciation in year 5 is equal to this 400 times 5, which is 2,000. This is the cumulative depreciation. And the book value in year 5 is equal to cost basis B minus the cumulative depreciation until year 5. So this is 4,000 minus 2,000. The book value at the end of year 5, as you can see, it is 2,000. Another method, which is also an easier method, is called the declining balance method. Sometimes this declining balance method is called as constant percentage method or Matheson formula. In this declining balance method, the depreciation amount at each year is not the same as the previous method, the straight line method, but here the annual cost of depreciation is a fixed percentage of book value at the beginning of the year. Okay, so the value, the depreciation amount is not fixed, but its ratio, its percentage is fixed. So what do we mean? We assume that there is an R, sometimes alpha is used here. It's a constant value, the ratio, and it is said that this R, for example, denoted in this way. If R is 2 over n, when we said to use 200% declining balance. If, for example, we are using 150% declining balance, then this R is equal to 1.5 over N. Okay, so this 200% declining balance or 150% declining balance are the referral, are the statements of this declining balance. And when someone says that 200% declining balance, then R is equal to 2 over N. Remember this, N is the number of years. And simply 100% declining balance, 100% declining balance means that this R is equal to 1 over N, and simply this is equal to straight line method. Okay, 100% declining balance means the straight line method. If it is 150%, 200% or more, then it has a different depreciation than the straight line method. So let's see, how do we calculate the depreciation amounts at each year? In the first year, the depreciation amount is simply the book value multiplied by R. So if R is 2 over N, let's assume that in our example, book value is 1000, N, let's say, is equal to 10 years. So D1 is calculated for a 200% declining balance. So it is 1000 times 2 over 10. Okay. So simply it is 200. And from here, the book value at the end of year 1 is equal to 1000 minus 200, it's 800. So this is the book value at the end of year 1. So if we want to calculate the depreciation in year 2, what do? We use the book value at the beginning of the year, which is 800, and multiply it by 2 over 10. And from here, we obtain the depreciation amount to be 160. Look, the depreciation in the first year is 200, and the depreciation in the second year is 160. They are different from each other. See? So in the straight line method, they would be the same, but in declining balance, and they are different. And as you can see, the depreciation in the second year is less than the depreciation in the first year. That's why it is called declining. The depreciation amount at each year reduces, declines. And as you can see, if you want to find the depreciation amount at a year K, what do? You simply multiply the initial cost basis. So in our example, it is 1000. You multiply it by 1 minus R. Remember, in this example, it was 2 over 10. So it is 1 minus 2 over 10. It says to the power k minus 1. Let's assume that we are trying to find the book value at the end of year 5. The depreciation at the end of year 5. So here we need to use to the power 4 times R, which is 2 over 10. So why is this so? Why do we have this? So in the example, next example that we are going to solve, you will understand it better. But the thing is, look, in the first year, when you depreciate this amount, find the depreciation using this 100, then the remaining book value was 800. What is this 800? That 800 is actually 1000 multiplied by 1 minus 2 over 10. So this is 8 over 10, and it gives you 800. This is the book value at the end of year 1. And in order to calculate here the depreciation amount in year 5, you need to find the book value in year 4 and multiply it by R. So actually this value over here is the book value at the end of year 4. And in order to find the book value, you simply multiply the initial cost basis with 1 minus R, okay, to the power those many years. And the cumulative depreciation amount until year K can be found by adding all the depreciations until that year. Okay, so you add up all these values after some algebraic operations, you get this. If you want to find the cumulative depreciation in year 5, simply it is b times 1 minus r to the power 5. That's it. And this is the book value at the end of year k, and this is the book value formula for the book value at the end of year n. Okay, so in straight line method, we said that from this initial cost basis to the final salvage value at the end, there is a straight line. It means that the depreciation in 1 year is equal to the depreciation in the second year, and it's equal to the depreciation in all other years. But in declining balance, the depreciation amount in the initial years, look, this is the depreciation amount in the first year, is larger than the depreciation amount in the second year, and it is larger than the depreciation in the third year, and it is larger than the depreciation in the next year. You see, the amount of depreciation reduces each year. And in the formula of this declining balance, we haven't used the salvage value at the end, remember. So what does it mean? It means that this declining balance method does not use the salvage value. It just reduces a percentage of the book value in each year. And it means that at the end of the useful life, the final salvage value of the declining balance method may not reach to the salvage value, may be higher than or larger than the salvage value. And in that case, we can switch from the straight line method to the from this declining balance method to the straight line method. So what does it mean? These two curves, as you can see, intersect here, and it means that until that point we use the declining balance method, and after this intersection we start using the straight line method. Okay, whichever is minimum, we use that alternative. Why is that so? Because as I told you, you are subtracting this depreciation as a cost from your taxable income to calculate your taxable income. And if you subtract more and more in the early years, it's for your own benefit because of the time value of money. So using declining balance method actually is beneficial than the straight line method because it reduces more amount in the initial years. But the thing is, since it will not reach to the final salvage value, because the salvage value is not in the formula itself, after some point you need to switch from the declining balance method to the straight line method. Okay, let's consider the same example that we solved, and let's calculate the depreciation amounts by using declining balance, but in the first part we will use 200% declining balance, which means that R is 2 over N. And in the second part, let's use 150% declining balance, which means 1.5 divided by N. Remember, in our problem, the initial book value was given as 4,000 and the useful life was 10. So if we use 200% declining balance, D1 value will be equal to initial book value multiplied by 2 over 10, which is 800, as you can see here. And then in order to calculate the book value, what we will do, book value at the end of year 1, we will subtract this 800 from 4,000 and the book value will be this much. Then in order to calculate the depreciation in year 2, we will multiply this book value at the end of year 1, which is this, with 2 over 10 again, and we will obtain this value. This is the depreciation in the second year. And when we subtract this value from this one, we obtain this book value. Then multiply this by 2 over 10 and we will obtain this depreciation amount, and subtract it from this one, the book value is this. And keep continue in that way. As you can see, at the end of the 10th year, the book value remains at 429. But remember, in this example, the salvage value was equal to 0. But when you use the declining balance method, you see the salvage value is not 0. But remember, what was the amount of depreciation in straight line method? It was all 400, right? We calculated this in our previous example. And you see initially, this 400 is less than the depreciation of the declining balance. It is less than the declining, it is less than, it is less. But here, as you can see, after some point, the straight line method is more than, the depreciation of straight line method is more than the declining balance method. It means that at this point we need to switch over from the declining balance method to the straight line method. Okay, if instead of 200% declining balance, if we use 150% declining balance, then what shall we do? Simply we will change the R in our calculations, and D1 value here will be 4000 times 1.5 over 10. Okay, 15%. It means that you will multiply it by 0.15 actually, and instead of 800 it will be 600. Okay, so here the first value will be 600 and this value will be 3400. Then you need to multiply this by 0.15 to calculate the next value, and etc. This is the only change when you use 150% declining balance. And this table actually shows how we switch over from one method to the other one. Look, we calculate, this is the original cost value with 200% declining balance. This is the depreciation amount, and this is the straight line method depreciation amount, 400. Okay, so since this depreciation is greater than the straight line method, we use the double declining balance method. So the next book value is initial book value minus this declining balance, which is 800, and we obtain this. Now look, we calculate the declining balance in the same way. Multiply this by 2 over 10, and we obtain this. But for straight line, now what we are doing, we do this at the beginning of year 2, we have 3200, and we will reach to 0 at the end of now 9 years. Okay, 1 year has already passed, there are remaining 9 years. So we calculate the straight line method starting from this one again, and we simply subtract this 0 and divide it by 9, and we obtain 355.56, which is this value. And now compare these two with each other. The value of the declining balance, the depreciation that we calculate by the declining balance, and the depreciation amount that we calculate by the straight line method. And since the depreciation in declining balance is larger, we select that one and continue. So we subtract this value, and this is the book value. Now, in order to calculate the straight line method, again, from this book value, we subtract the salvage value and divide it by, now we have 8 years to 8. And from here, we calculate the depreciation of the straight line to be this much. And we compare this with each other. Since this is larger, we select the declining balance. We continue to do this in this way. And as you can see, when we are in year 6, we see that both of them have the same depreciation amount. So this is the point of intersection. And at this point, we change the method from declining balance to straight line. From now on, we don't depreciate using the declining balance, but we continue with the straight line and we subtract this constant amount. And how did we calculate this amount? Simply it is 1310 divided by minus 0 divided by 6, which is the remaining amount of time. Actually, the remaining time is not 6 years, but 5 years. So we divide by 5 and we obtain from here 262.14 as the straight line. Okay, so this is the switch over point. This is important how we calculate. And if you look at the graph of these, in this declining balance, you will have such a curve. In the straight line method, you will have this curve. And this is the point of switch over, which is year 6. Until year 6, you use declining balance. And after 6, you use straight line method. So at the end of 10 years, you reach to 0 book value. If you continue to use the declining balance, your final salvage value will not be equal to 0. The final depreciation method that we are going to learn has a difference between these straight line and declining balance methods. It's called the units of production method. So we said that the depreciation is the loss of value due to time or loss. And declining balance and straight line methods consider the time. Okay, they were functions of time. But units of production method is not a function of time, but it is a function of use. Okay, as the name implies, we will think about how many units we produced, or if it's a car, how many kilometers we traveled with this car in order to calculate the depreciation amounts. So this method results in cost basis minus final salvage value, like the straight line method, being allocated equally over the estimated number of units produced during the useful life of asset. So let's be more specific, more clear. In order to calculate the depreciation per unit of production, per unit of kilometer in a car, what do? Initial book value minus final salvage value, like exactly the same as the straight line method, divided by the estimated production amount, number of products that can be produced during the lifetime. So we can say that if this is a car, let's assume that we bought a car for $10,000 and the final salvage value at the end of, let's say it's 20-year useful life, the final salvage value is $1,000. And in these 20 years of time, assume that this car can travel for 1 million kilometers. Okay, so this is the estimated number of kilometers that you can travel within the useful lifetime. So when you do this calculation, you calculate the depreciation amount per unit kilometer or per unit produced with this machine. Then you can use this to estimate the depreciation at each year. Let's see how we do with an example. So it says that a piece of equipment used in business has a cost basis. B is 50,000 and expected to have 10,000 salvage value. Okay. And when replaced after 30,000 hours of use. So the total amount of production, number of units, let's say, is equal to 30,000 hours. So this number of units can be kilometers, can be hours, can be a number of products. It can be different depending on the property, the asset. And it says that find its depreciation rate per hour of use and find its book value after 10,000 hours of use operation. Okay, so what do we do initially? In order to calculate the depreciation rate per hour, we will subtract from this 50,000, we will subtract 10,000 book value minus salvage value divided by 30,000. Okay, simply if you do this calculation, you will obtain 1.33. This is depreciation amount dollars per hour. Okay, so in 1 hour, your item depreciates $1.33. Okay, this is the first part, depreciation rate per hour of use. And in the second part, it says that find its book value after 10,000 hours of production. Look, it doesn't say that find its book value at the end of first year, second year. It says that find its value after 10,000 hours of production. So what is the total depreciation amount for 10,000 hours? It will be 10,000 multiplied by 1.33 dollars per hour. So it will be 13,300. Okay, this will be the total depreciation amount dollars, and the book value will be initial book value, which is 50,000 minus this depreciation amount. Okay, this will be the book value. Okay, so this is the solution. 50,000 minus 10,000 divided by 30,000. This is the depreciation rate per units of production per unit. And from this initial cost basis, if you subtract this depreciation amount, the book value can be calculated as this much. So this is the end of this lecture and our discussion in this topic. We learned the concept of depreciation in this chapter. We learned several terminology related to depreciation, and we learned three methods of depreciation: straight line method, the declining balance method, and the units of production methods.